Hello, thank you for listening this talk. I'm Koichi Sasada from Cookpad. This year, I made a brand new debugger named debug.gem, so I want to introduce this term in this talk. So that this talk introduces debug.gem. Debug.gem is already released, and you can use this debugger with Ruby 2.6 or later. This debugger will ship with Ruby 3.1, which will be released in December this year. Ruby 3.1 development branch already merged debug.gem, so you can try Ruby 3.1 and this new debugger. New debugger has many novel features that were not previously available in Ruby world, so I hope you enjoy new features. This talk demonstrates this new debugger, the basic usage and advanced features. The presentation slide with this talk script is available at this URL. Please enjoy. Let's introduce myself before the presentation. I'm Koichi Sasada, one of Ruby interpreter developers. Usually, I develop Ruby internals such as virtual machine and garbage collector and so on. Last year, I was working on Ractor implementation for Ruby 3.0. This year, mainly, I spent my time to make this new debugger. Before I introduce new debugger, I summarize what is the debugger. The main purpose of debugger is to help debugging your applications. When we get a bug, we need to investigate the cause of problems. If we got a bug, at first, we check the backtrace to know where the issue comes from. Also, usually, we use printing the program state with P or PP method in Ruby. Sometimes you may use binding.break or binding.ARB methods to use REPL, read, eval, print loop console on the specific binding. Another purpose to use the debugger to understand the program. To understand the program, learning the program is one of the best ways. When you want to know the program internals, you also need to use print method or REPL console. To help such cases, debugger provides useful features. Debugger enables to control the execution, for example, specifying the breakpoint we want to stop, and steps forward only one line, and so on. Also, debugger helps to show the program state, such as local variables, and so on. In the Ruby world, we already have several debuggers. libdebug.rb is standard library which is available from Ruby 1.0. However, maybe nobody uses it and not maintained well. I think debug is most popular debugger for Ruby in recent days. Debase or Ruby Debug IDE is also popular because they are backend of RubyMine or VSCode IDEs. So we already have Ruby's debuggers, but I decided to make new debugger because of several reasons. One reason is the performance of existing debuggers. When we use breakpoints in a program, existing debuggers can become slower to check breakpoints. Recently, we introduced new TracePoint features to solve their slowdown, so we can improve the performance of debugging. In other words, we don't need to hesitate to use the debuggers on development. Also, I want to provide IDE integration on default. Sometimes the debugger console is useful, but sometimes it is hard to use it. For example, we need to use the break command with file and line, or to write bybug method, for example, in the application to specify the breakpoints. but I want to specify breakpoints by clicking the editor's source code directly. Another example, if we print the nested data structure, it can be huge output. I don't want to see 1,000 lines of output from nested data structures. I want to expand the output by clicking the output like JavaScript console. Usually, IDE provides such interfaces, so it is more natural to utilize these features. Another reason is Ractor. Ruby 3.0 introduces new Ractor mechanism which isolates the object space, and the existing debugger doesn't support it. Unfortunately, kind debug.gem does not support Ractors yet, but it is one motivation. One more little but biggest motivation for me is I like to make this kind of tool. It's technically difficult a bit, and it's useful to have. Okay, let's introduce the debug.gem. This talk does not explain how to use new debugger, but explain what kind of features new debugger provides. So please check out the documentation on the GitHub to know how to use. We wrote everything on README, about 1,000 lines. Debug.gem was created from scratch this year. Gem is already released, so you can use it by gem install debug command. It supports Ruby 2.6 and later because it uses recently introduced API. Ruby 3.1 released soon will be shipped with this debug.gem to replace old lib debug.rb. Like other debuggers, such as Bybug, GDB, and so on, debug.gem provides a REPL which accepts debug commands to investigate the bugs interactively. To use debug.gem, mainly there are three ways. The first way is use rdbg commands like bybug or gdb commands. You can specify Ruby script or external commands with -c option. The second way is rewrite your application to require a debug library or rewrite your gem file. I think Rails developers like this way. The third way is to use IDE. For example, on the VSCode, you need to set up the launch.json file in your workspace. Fortunately, Ruby RDBG extension I made creates a default setting, so you don't need to see the details. After that, you only need to push the Start Debugging button to start debugging with debug.gem. Let's see the basic demonstration of RDBG command. Invoke the RDBG command with the target script, then it invokes the Ruby interpreter with debugger and stop at the beginning of script. This arrow shows where the script is stopping. We can use the step command to move to the next line, and next line, and next line. Empty line means repeating the previous command, so we can repeat the step command here. And we can see the local variables with info command. In this case, local variables a and I are assigned, and j and r are not assigned yet. We can step into the method who, and we can see the backtrace here, and with the given parameters. When the method is returning, we can see the return value here, and we can continue the rest of program with continue command. This demonstration shows debug.gem and VSCode integration. You can start debugging by menu. You can specify what kind of program you want to run, and the program runs with debugger. In this case, there are no breakpoints, so the program terminates immediately. Let's specify the breakpoint with typing F9 key on VSCode and run debugger again. You can see the program stop at the breakpoint. As you can see, there are local variables view, and you can expand the nested data structure by clicking it. You can control the execution by pushing the control buttons on VSCode. As you can see, debug.gem provides basic features which are provided by other debuggers. To specify the breakpoints, there are three ways. One is to use break command on the debugger's console. You can specify files, lines, method names, and raise exceptions. Also, you can specify conditions you want to break the execution. Another way is to write binding.break in your application like binding.break or binding.irb. There is show to binding.b method or simply debugger method in kernel like JavaScript. If you can modify the source code, it is an easy way to specify the breakpoint before execute the program. The last way is using the IDE breakpoint features. Now we only support VS Code, but we can increase the support platform like VIM editors. Using break command or using IDE support, we don't need to modify the source code. I think it is the easiest way to use IDE support to do it. Writing binding break method in your application is well-known style like binding.break. You can control breakpoints with your application code. Another interesting idea to use binding.break method is using with do keyword. If do keyword is given, it doesn't stop the execution but executes the debug command. In this case, it enables trace feature before the invocation of var method and disable it after var method. You can see the trace information only for var method execution. In general, a debugger target program cannot communicate with an underlying debugger. This feature achieves it, and you can use debugger's feature in your application. Debug.gem provides a normal execution control feature step in, step over, and step out. Step in by step commands stop after next breakable line. So using step command here, then enter the foo method and stop at this line. Step over by next command stops at just next line, so it doesn't stop at the method bar, but stop at here. And when we use step out feature used by finish command, then it stop just after returning the current scope, so it doesn't stop here or in the method bool, but stop here. When the program stops at the breakpoint, you can see the backtrace with given parameters like that. With debug.irb, you can see only the specified binding. But with the debugger, you can access any bindings in the backtrace by specifying with frame command. And you can check the variables with info command or outline command like that. Outline commands is same as price ls command. Of course, you can evaluate Ruby expression in the debug console. I introduced basic features which are supported by many other debuggers. Next, I want to introduce the advanced feature debug.gem provides. Today, I'll show 4 features. At first, debug.gem supports remote debugging feature. You can open debug port by using rdbg command with open option. After that, you can attach to the port with rdbg attach command. And the attach program will pause the execution. TCP/IP and Unix domain socket are supported to communicate. I think it helps to debug no TTY processes like daemon processes, redirect processes with shared pipeline, and remote machine processes. If you open the debug port, anytime you can attach to the processes and check the program state, so it will help the development. Let's demonstrate the remote debugging. Starting the program with -o option on rdbg command, and debugger port is opened, and the program stops at the beginning. On next terminal, start the rdbg command with -a option. It's attached to the opening debug port, and you can see the debug console. You can control the target program with any debug command remotely. Next advanced topic is seamless integration with VSCode and Chrome browser. If you start the debugging with the debug console, but you want to browse it on the VSCode, you can open the VSCode with open VSCode command. Like that, wait a second, VSCode launches automatically, and debugging can be continued on VSCode. You can also use Chrome browser as a debugger frontend. Same as open VSCode command, you can use open Chrome command, and we can see the URL. Put this URL into the Chrome browser, and you can invoke the Chrome's debug frontend and continue the debugging on the Chrome browser. You can specify VS Code or Chrome for the debugger frontend with open option. If you are not using VS Code to modify the source code, but you want to use VS Code as a debugger frontend, this feature will help you. Next example is Postmortem debugging. This program stops because raising the zero division error. But we can enable Postmortem feature, and you can enter the debug console when the process terminates with the exception. You can see the variables as the exception is raised. So it will help to investigate the issue. The last advanced feature today I want to introduce is record and replay debugging. If we enable this feature, we can record the execution information and step back to the execution by step back command. This feature helps if you want to check the last status before the breakpoint. This feature is not optimized, so it consumes time and memory, and it is not feasible to use it on entire execution, but we can use it with some limited lines. You can use this record and replay debugging with VSCode. Start the debugging and use the step back button, and you can see the previous status. At the start of this presentation, I talked that one of the motivation is debugger's performance. This figure shows how this program becomes slower with debugger when we set the breakpoints. With bypass 80 times slower than normal Ruby execution. RubyMine also makes it 24 times slower. Old libdebug.rb slows it about 300 times slower. However, as you can see, with debug.gem, we don't see any performance penalty on this case. At last, let me show acknowledgements. Ono-san helps me to make test framework for the debugger and Chrome browser integration feature. The test framework is achieved by the Google Summer of Code this year. Stan Lawson submits many patches to improve the debug.gem. He suggested many useful ideas from the Rails user perspective. And many people helped me. Thank you so much. This is conclusion. Debug.gem is newly created Ruby debugger from scratch. It is fast, it has modern user interface, and it provides many features. You can use it now by installing this gem. This gem is not matured, so your feedback will help us. If you need an advice or if you have any requests, feel free to contact us. Thank you for your listening. I hope this debug gem will help your development.